Lectures. There we go. So I hope you guys are ready. Okay, it's about noontime, and I'm going to start the lecture, even though I think not the entire class is here yet. But you probably will notice that I do not wait, so I just go ahead and get started. The lecture is getting recorded. Okay, some of you already know that I record basically. If I can, I record all my lectures. Sometimes there can be technical difficulties, which means it's always a good idea to take notes. Okay, um, so there's that. I'm Tack, by the way. I'm teaching CISP 440. So if you're not in here for CISP 440, you're in the wrong classroom. All right. Um, I suppose you guys have read the syllabus because I sent an announcement to ask you guys to read the syllabus before the first day of class or the first class meeting. So is that okay? I mean, can I make the assumption that you have read and understood the syllabus? Okay, I see some nods. Okay, so I'm going to give you a short quiz that doesn't count for any points. Okay, if somebody just goes like, I just need to pass this class with a C, what is the percentage of the score to pass this class? Okay, okay, people from my previous class, do not say anything. So I want the rest of the class, okay, to think about this. If you know the answer, good. If you don't know the answer, you might not have read or might not have read thoroughly the syllabus. Okay, so what do you, so think about your own answer, okay? If you have the answer, good. If you don't have the answer, well, maybe you need to go back and read the syllabus again because I make the assumption that you have read the syllabus, which basically means once I execute, the rules, based on the syllabus, I don't want someone to come back and complain, but I didn't know. Well, did you read the syllabus? Uh, yeah. So I don't want that situation to happen. I don't want it to happen to you. So the answer is 37.5%. Okay, if you had read the syllabus, that would have stood out because it's different from all of the other classes. Are we good so far? Okay. Does that mean it's easy to pass this class? Okay. Okay. All right. So with that out of the way, because I did not want to use class time to talk about the syllabus when you can read it. So for those of you who go like, but I don't have the attention span to read the syllabus, what do you think is the answer? What do you think I would give you as an answer when people say, I don't have the attention span to read the syllabus? Hmm? Text to speech, upload it to YouTube or not YouTube, upload it to Gemini and ask for a summary. Okay. In fact, you might want to do that. Okay. Upload the syllabus. So every time you have a question like, how many times can I be absent in class and not get dropped from the class? Well, have the AI to answer the question. Okay, so those are the things in the syllabus. Okay, if you have read it, it's even better. Okay, but at least try to rely on an AI to give you answers to those particular questions because, well, I do keep track of whether people are in class or not. So I'm going to take roll, okay, in just a little bit. If you have a mobile device that you can use to sign into Canvas, great. If not, use the computer in front of you. Okay. Now, how many people do not understand that there's a computer in front of you, like this whole time? You guys all know that. Okay, very good. So that means when I want to take roll, you guys will know, okay, I can either do it on my cell phone using Canvas, or I can use the computer that's already in this classroom in front of you. Okay. All right. So with that said, we are getting started. Okay. We're getting started in at least two ways. Um, First of all, I'm going to check the prerequisite and the co-requisite for this class. The prerequisite is just the math. You have to have taken and passed Math 370 or 372 to meet this prerequisite requirement. And for people who cannot show me that they have met the requirement, they will be dropped, on the due date, which is, next Monday, um, from this class. So that usually is not a problem. The problem usually is the second one, which is this class also has a co-requisite of CISP 430, which means you need to have either taken and passed CISP 430, the data structure class, or you are concurrently enrolled in that class. It doesn't matter which campus, okay, but you need to be enrolled in CISP 430, in the same semester as this class, or have taken that class already. So I will check those two. Okay, so both of these are quote unquote assignments. If you already have a score of 1/1, that means I have checked it already. You're cleared. You're all good to go. If you see a 0/1 or a dash/1, that means you need to somehow turn in some kind of paperwork to convince me that you have met that requirement. Do we have any questions about the prerequisite checking and also the co-requisite checking? No questions? Okay. Now I did take a look at the where people took classes. People coming from Folsom Lake, I think you need to pay attention to this because at Folsom Lake, CISP 430 is not a co-requisite, but the co-requisite requirement goes with where you are taking 440. So that's why I still have the co-requisite requirement of CISP 430. All right. So I'm just going to move on then. Okay. This link will link you to all the lecture recordings, including those from the past 12 years or so. Okay. So you can always know what I'll be talking about next if you just look up the past, lecture recordings. Okay. In other words, you can kind of plan ahead of time, watch a little bit of the recording from the past, then you have some idea of what I will be talking about, which is always helpful. Okay. All right. So we are moving on to the next one, and we're skipping these two because I don't think they're useful. So I'm going to go all the way to Boolean operators. I sent out a link this morning, urging people to kind of at least take a look at it. So if you have taken a look, great. If not, I guess it's not too big of a deal because this should be a mostly review for you and not new material. But in the future, okay, for next Monday, it will be very important if you read the reading material ahead of the class, because this way, at least you have some idea of what I'll be talking about. And if, as you're reading the material and you go like, I'm not really sure what you mean by that, jot down the question so that by the time we talk about that, you can kind of bring up the questions if I do not address your question just by the lectures. Okay. Are we ready to go? Are we ready to move on? Okay, excellent. So we're going to start with Boolean operators. And, as I said, it's mostly a review, okay, although there are some new stuff introduced here. So we're going to start with the concept of a conjunction. The concept of a conjunction is basically the English word and. The mathematical symbol is, this is called the wedge symbol, okay? And the Boolean operator, the truth table, looks like this. So we have x and y being Boolean variables. They are independent. So what that means is the value of x as a variable does not depend on the value of y as a variable. They are completely independent. So on the first row, do we all know how to read a Boolean truth table, or should I explain that too? Nope. No questions? All right. Sure, no problem. So on the first row, it means when x has a value of x of 0, y has a value of 0 also, then x and y has a value of 0. So in this class, 0 typically means false and 1 means true. Okay, so instead of spelling out true and false, I just use 0 to represent false and 1 to represent true. Okay, so that's just a little shorthand thing. So I'm going to pick another row all the way down here. So on this row, it means that when x is a 1, y is a 0, then 1 and 0, or true and false, is also a false. So is that okay? Does that help explain how to read the truth table? Okay, all right. So in this case, we also have different notations. So these are the different notations of conjunction. This one you should be familiar with because you have taken CISP 360, and that's pretty standardized, as the conjunction symbol across most programming languages that are C-based. Um, so do we have any questions about what ampersand ampersand mean in C or C++? No? Okay, well, then I'm going to ask you a question. Okay, so what is the value of this expression? But in C and C++, in C, in regular C, okay, in NCC, not C++, there is no such thing as true. So what you can only be guaranteed is this expression evaluates to non-zero. That's all you know. Okay? Can they give you an answer of 2? Yes. Can they give you an answer of 1? Yes. Can they give you an answer of negative 216? Yes. Because all of those are non-zeros. Okay? Because in C, not so much in C++, but in C, 0 is false. Non-zero is true. So we have non-zero, which is true. We have non-zero, which is true. We have true and true, which is supposed to be true. But because C does not have a Boolean type, so it will give you back an integer that is non-zero. But which non-zero integer value is going to give you, that is not part of the language specification. Are we okay with that concept? Did the professor talk about this concept in CISP 360? No? Okay, that's a really, really important concept. Okay, so now let's go take a look at another expression. Okay, what is the value of 2 single ampersand 3 instead of double ampersand? The question now is, did the professor also talk about bitwise operators? Because the single ampersand is bitwise and. So what is 2 bitwise and 3? Nope, it's just 2. So this is really just 2 for sure. Okay, the reason why it is 2 is because 2 itself is 1 0 in base 2, 3 is 1 1 in base 2. So when you perform a bitwise AND, 0 and 1 is a 0, 1 and 1 is a 1. So the result is 1 0 in base 2, which is 2 in decimal. So that's a bitwise AND operator. In most programming, bitwise AND is not particularly useful. On the other hand, if you want to do any type of low-level programming, bitwise operators are super useful. Okay, they're really critical for low-level type of programming. All right, so this is the mathematical symbol of AND. If you are into computer engineering, they also use multiplication or what looks like multiplication, like this or this, to also mean conjunction. So these are the notations to mean exactly the same thing, x and y, x logical and y to be exact. So are we good with those 4 notations? Okay. So the important thing is, from time to time, I would use one notation over the other notation. So it is important for you to understand all 4 of those notations. And if I were you, I would kind of dedicate a page on my notes just for notations. Okay, because this way it's easy to look up things, and the process of writing notes is helping you to remember things already. Okay. So are we okay with that concept? The concept of taking notes. Okay, all right. So I can also kind of mention a little bit about why we need to take notes. Okay, so can somebody tell me why, generally speaking, it is important to take notes? Why you should have at least a notebook in front of you, a writing instrument, you know. Now, whether you write down something or what you write down is kind of another question to ask, but it's always important to have a way to take notes. So why is that important? Yes, it helps to, it does two things. One is it gives you a record of what was talked about in the class. Okay, so that's one. And then the second one is to help reinforce so that you can start to remember the things that we talk about in class. Because if you don't do that, we only have short-term memory. So how short-term are we talking about in terms of short-term memory? Are we talking about a scale of single digit or double digit seconds, or are we talking about minutes, or are we talking about days? Single or double digit, okay? Typically, people have a double digit thing. So if I just give you a bunch of random things to memorize, okay, in about 20 to 30 seconds, it'll be lost, okay? So that's why, we kind of need to take notes because, the effect of losing that memory is not obvious in the class because I keep talking about the same thing. So every time I talk about it, it's like a refresh. Okay. So since you're experiencing the constant refresh when I talk about it, you don't realize that if I stop talking, the moment you walk out of the classroom, by the time you get to the elevator or the staircase, poof, it's gone. Okay. So that's why it's important to take notes. So how does taking notes help you remember things? Okay, what is the mechanism? Because when you're listening to something, it goes through one particular pathway in your brain to understand stuff. Okay, when you look at something, when you're reading, it goes through a separate path. So some people are better with reading, some people are better with listening, but when you try to write something down, it goes through a third pathway. Okay, so the more pathway you engage in your brain on the same topic, the more pathway you have to relate the concepts and to remember things. So that's why it is important to do this, to write notes. Okay, all right. So I have already talked about writing notes. Okay, so now we can move on to disjunction. So disjunction is or in English. It is the vertical bar symbol in C++, but in mathematical notation, it looks like a V, but it's not really exactly a V. So we have the truth table of false is false or true is true, true or false is true or true is also true. So I hope that is not a surprise to anyone in this class because that's one of the really kind of important and elementary logical operators that we learned in just about any programming language. So the notations for or disjunction is the usual one, which is the C++, symbol. We have the mathematical symbol. And in the context of computer engineering, and also in this class, sometimes I would also use the plus symbol to mean disjunction. So the meaning of the symbol is context sensitive. So that means what that means is if x is Boolean and y is also Boolean, then the plus simply means disjunction. Do we have any questions about the notations of OR, logical OR? So how does logical OR compare to exclusive OR? Can somebody give me an example of the use of exclusive OR just in a natural language context? Go ahead. Yep. Okay. Yep. I think you understand it. So we're going to take a look at it using perspective of a truth table. Okay, so we have x, y, and then we have x. This is the symbol of exclusive OR. It looks like a plus with a circle in it or around it. So once again, the truth table has how many rows? We have two independent Boolean operator or Boolean variables. So how many rows are we talking about? Four, exactly. So we have exactly the same four combinations of false, true, like so. Whoops, this is a true, true over here. So just like OR, regular OR, Zero exclusive OR with zero is a zero. Zero exclusive OR with one is a one. One exclusive OR with zero is also a one. This is the only row that's different. Okay, one exclusive OR with one is actually a zero because it is exclusive, which means only one and only one side of the operator can be true for the entire operator to be true. Is that okay? All right. So we don't really use exclusive OR too much, but I do want to point out that exclusive OR is not regular OR. Okay, so there's OR, there's exclusive OR, they are not the same thing. All right, so we move on to negation. Negation is essentially the word not in English, and the mathematical symbol looks like a cliff. If x is false, not false is true. If x is true, not true is false. So that's one of the simplest operator in terms of logic. So in terms of the representation in C and C++, it is at the exclamation point. In terms of mathematical notation, it looks like a cliff. In terms of computer engineering, it can be either one of these. It can be X with a bar on top. It can also be represented as a slash followed by by the value. So one of these can be used, in the context of computer or electrical engineering. In computer science, typically people don't have to deal with negation with those particular symbols. So in computer science, in programming, we just use the exclamation point to mean logical not. So are we okay so far? All right. So does anyone know what tilde means? Tilde is this symbol here, the squiggly, which is also shift backtick. It is called ones complement because it is flipping all the bits from 0 to 1 and all the from 0 to 1 and 1 to 0. Okay, so something that starts with a 0, it becomes a 1 and so on and so forth. So if I ask you what is tilde 5, okay, then the first question you have to ask is how wide is the integer? Okay, so let's just say that this is a 16-bit, okay, just so that I don't have to write a bunch of zeros and ones. So in 16-bit, 5 is known as 101, and then fill up the rest with all zeros, right? So we need 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That is 5 represented as a 16-bit number. Is that okay? So if you use the tilde symbol, which is bitwise not, then you are performing a not or logical negation operation on a per bit basis. So that means the bitwise not of this would be 0, 1, 0, and then the rest will all be ones. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. There we go. So this is x, and this would be the bitwise not of x. In this class, we don't use bitwise operators, so you don't have to worry too much about it. But it is important to understand that C and C++ does support bitwise operators. Bitwise not looks like it is really useless, but in conjunction, no pun intended, with and or, it is actually really useful for singling out specific bits of a bit pattern. It is not useful in general programming, but it is really useful when you want to do low-level programming, which means, oh, here's a great chipset, okay, for you okay, these days it's going to be eSATA, okay, your hard drive interface. So let's say you have a chipset, okay, it controls the eSATA, connections to all the drives. In those cases, the controller will basically dedicate specific bits of a I/O or input-output register for certain types of functions. You have to be able to single out individual bits in order to tell the driver, in order to tell the chip, what to do with a specific channel of eSATA. So if you're going into low-level, type of programming like device drivers, embedded systems, and stuff like that, bitwise operators are actually really important in your life. Okay, but once again, this is CISP 440. We are not going to use bitwise operators for the most part in this class. All right, so you would think that we are done with all the operators because these are the operators that you learned in CISP 360, that you have used in CISP 400, and now in CISP 430. But in logic, there are some other there are some other operators that are particularly useful. I don't know whether I want to skip over this or not, okay, but I think we should probably just kind of talk about it a little bit. So this is a NAND operator, NAND, which stands for negated AND. Okay, that's what the first AND is means. The first AND means negated. So the way negated AND means is exactly that. The arrow symbol is usually used to represent the operator. So when I want to say x NAND y, we use the up arrow thing to mean the operator. So x NAND y by definition is the negation of x and y. So if you want to use the regular C++ notation, it would be the same as exclamation point x and then ampersand ampersand and then y, but you have to put x and y in parentheses because the negation applies to the conjunction. Is that okay? Does everybody understand the definition of NAND or negated AND? Okay, so now the question is, well, that looks pretty useless because if it was useless, we would have learned it in CISP 360. Well, CISP 360 was only the first class in computer science. Okay, so what NAND is really cool, why it is cool, is because you can use this one single operator to emulate the other operators. In other words, if you just want to say the negation of x, you can use the NAND operator and say it is x NAND x. Okay, what about the usual AND, the not negated AND? X and Y can be re-expressed as X NAND Y NAND X NAND Y. What about OR? Logical OR, X or Y can be expressed as X NAND X NAND Y NAND Y. So I just gave you a bunch of baloney, okay, a bunch of statements, okay, and so what do you do about that? Build your own truth table to establish the equivalency, okay? Because we have the definition of NAND, right? We already know what is AND, what is not, and what is OR. So you should be able to make a truth table to make sure that this equivalency, and this equivalency are valid. Okay, it is always important to look for ways to verify what I tell you for a few reasons. One, sometimes I misspoke. Okay, sometimes I would say something incorrectly. Okay, accidentally, not intentionally. And then the second thing is this is how you can quote unquote give yourselves quote unquote homework assignments. Okay, you look at a certain statement, text says it's true. Okay, don't just take it. Okay, try your best to utilize what you have already learned to prove that that statement is actually true. Because in that process, you are reviewing the concepts that you have already learned. You're trying to apply what you have learned already to prove a statement that I'm making. That is basically just applying what you have learned. The more you do this, the more you apply what you have already learned to validate statements like this kind, then the more familiar you are with the material. Is that okay? Okay, so you're asking questions in your own head. It's like, okay, but how do we know this? Okay, how do we know, this side, the left-hand side is the same as the right-hand side? You can totally do it. Okay, and in doing so, you're giving yourself an opportunity to practice, what NAND is actually doing. All right. So getting back to why do we even mention this negated AND operator? It is kind of cool because if I want to design a minimalist programming language, I don't need to give you not, I don't need to give you and, I don't need to give you or. All I need to give you is NAND. But that would be a pretty painful programming language to use, I have to admit. Okay? So, doesn't seem like NAND has any real life practical application. So, are you all computer science, or does anyone in this class want to get into either electrical or computer engineering? Computer or electrical? So, you're leaning to the lower level stuff? Okay. Anyone else? Okay. Computer science and engineering. Computer engineering? Okay, very cool. So, why do you think this is particularly important for computer engineering or electrical engineering? Yep. Yes. So the really cool thing is you don't have to make that chip. The chip is already made. There are chips with a bazillion, yes, that's a unit, with a bazillion NAND gates. Okay. What you do is you specify how the NAND gates connect together. So you can route the output of a NAND gate to the input of another NAND gate, and so on. Okay, it's really flexible. That kind of an IC or integrated circuit is called an FPGA. You can look it up if you want to. So it's called FPGA. So FPGA stands for Field Programmable Gate Array. Okay, that's what it stands for. So it is really cool because most cell phones probably have an FPGA of some kind. So what an FPGA can do is it can come it basically it is unprogrammed. Okay, when you power up your device, you actually have to load the configuration of how you want the NAND gates to interconnect on the chip. So what you can do is now you have a cell phone, and by the time your cell phone needs to be released, okay, um, you have to push because marketing says we promised our customers that we're going to release this brand new cell phone on this date. We cannot delay development any further. So what you do is just release it. Okay, even though you don't have the perfect, let's say, voice compression or environmental noise cancellation algorithm done, you go like, we are just halfway done. We're not fully done. Okay, it works, but not all the way that we wanted. Okay, you release the product. Okay, with an FPGA, you can use the FPGA to do the acoustic processing, do noise canceling. You can do voice compression, compressing the voice to use as few bandwidth, as little bandwidth as possible. So you can now do updates afterwards. Okay, just like you can update an app, you can now update quote unquote hardware. Okay, how cool is that, right? So depending on how somebody is using the phone, you can also dedicate the FPGA to do different things. So for people who don't use the phone for voice at all, okay, the same FPGA can be used for, let's say, graphics processing. Okay, it can be used for user interface processing. It can be used to enhance um, the processing of the accelerometer. Okay, does everybody know what is an accelerometer? It's a sensor that can sense force or acceleration and deceleration to be in physics, right? So if you can have high accuracy and high sampling rate, you can do what we call dead reckoning. In other words, you just program your phone, okay, and you say this is in STEM building 305, right? Okay, and then you just run around the STEM building, okay, without using the use of any GPS or any beacon signal. And then you come back to exactly the same spot and you ask, where am I now? It will say, oh, you're at exactly the same spot as you were because it's tracking all the motion. Okay, it's tracking all the acceleration, all the deceleration, and depending on the sensor, it can track rotation and whatnot. So if you have high accuracy sensor combined with the processing of that information, you can use dead reckoning to figure out where you are once you know where you start. So you can kind of imagine that can be useful because basically when you walk into a department store before you lose your Wi-Fi or your GPS signal, okay, you sync the location and your orientation right at the entrance of a store. Let's say Walmart, right? You get the app, okay, of a Walmart with the interior, layout, where you can find the potato chips and whatnot, right? So as you're walking inside the Walmart, you kind of need to know where your current location is because after the potato chips, you probably want to go get some salsa. Okay, so where's the salsa? Oh, it's 6 aisles down over that way. The phone knows exactly where you need to go. The question is, does the phone know where you are, so that it can guide you to where you can find the salsa? So with dead reckoning, it means you can be on in airplane mode. Okay, no GPS, no Wi-Fi, no Bluetooth, nothing. The phone can still guide you to that location. I think that is kind of cool. Okay. So the FPGA can allow you to say, oh, since you're not talking on the phone, might as well use the FPGA for this purpose. So you can repurpose the FPGA depending on what app you are using. And then you can enhance your processing that would otherwise be using the main processor. But if you offload that kind of processing onto an FPGA, it can do it with higher efficiency, which means you extend your battery life tremendously. I think that's also a great thing, right? Otherwise, by the time you find your salsa, your phone is dead because it consumes all the battery power. That would not be cool. So, so for those of you who are getting into computer or electrical engineering, the NAND gate is cool because that's how FPGAs are implemented. And there are different kinds of programmable logic devices. FPGA is one, EPLD is the other one. So depending on whether you want it to stay programmed after you power off, there are different options. But nonetheless, the whole point is these are programmable devices. You can use it for different things. Okay, and then for someone who has taken CISP 310, you go like, I wonder if I can implement text toy processor using FPGA. Yes, you can. Okay, you can actually turn it into hardware and watch it run. So that's kind of cool. Anyway, so I want to give you guys context of why we talk about specific concepts in this class instead of just go like, okay, just remember this stuff. I want it to be more applied. All right, so the next operator is implication. So implication is represented usually using either a single or a double bar right arrow. Okay. In this class, I use double bar because the single bar right arrow is used for something else. Okay. So in this class, we use double right arrow to mean X implies Y. So for those of you who want to get to uh, the gritty implementation detail, X implies Y is actually the same thing as not X or Y. So that's one way to re-express X implies Y using operators that we are familiar with. So X implies Y is not X or Y. But for the other people who just want to look at the truth table, this is the truth table of implication. False implies false is true. False implies true is true. True implies false is the only time you get a false, and then true implies true is also true. Okay? So if you're having some, challenges, mapping the concept of implication to the truth table, just remember the truth table. Okay? Just don't ask, what the word means. Okay? For other people, if you want a more semantic or intuitive explanation of why the truth table looks like this, so I have an example here. I'm not sure I want to go through the example because it can be confusing to some people, but it also helps other people to understand implication. But basically, this boils down to what you need to know about the operator called implication. Implication is not an operator in C++ because it doesn't really need it. But in a class like this, implication is actually really important. So that means you might want to put the implication operator definition to some place in your notes so that it's easy for you to find. I forgot another reason why people might need to take notes in this class, the exams. Okay. Okay, this is another quiz to see whether you actually read the syllabus or not. How many exams do we have in this semester for this class? Three, that is correct. Okay, so we have exam one, which is about at about one third through the semester, exam two, which is about two-thirds through the semester, and then we have the final exam, which is at the end of the entire semester. So what is the percentage of the first exam? Okay, people who took classes from me, please refrain from answering that question. So what is the percentage of the first exam of this class? Okay, so I guess some people need to read the syllabus again. It is 20%. Okay, the second exam is also 20%. All the homework assignments add up to 20%. So what do you think is the percentage of the final exam? If you have been keeping track of those numbers, right? 20% plus 20% plus 20% is 60%. So what is left? 40%, right? Wait, Tag, did you just say that it takes 37.5% to pass this class? Yes, I did. And yet the final exam is 40%. Yes, that is true as well. So does that mean that I don't have to turn in any homework assignment, completely flunk the first and the second exam, ace the final exam, and then I have my pass for this class? The answer is yes. But please do not interpret what I just said as a challenge, because I know some smart people like a challenge. It's like, I bet you I can do this. Okay, so don't take it as a challenge. Okay, just it's just how the math works out. Okay, so don't take it as a challenge. And I lost track of my train of thought. Yeah, I'm not sure I want to do that, but let's go ahead and do it. It's kind of fun. All right, so I'm gonna give you. I'll charge every person in this class like $50 for, you know, words of wisdom of some kind. Okay, so you pay me $50, and I just said, okay, today's word of wisdom is a blue cat is sick implies tomorrow is doomsday. You go like, what? I paid $50 for that? I want a refund. Okay, I say, well, you can get a refund only if the implication is false. Only if that statement that you pay $50 for is not true. That's the only time you get your refund. Is that okay? Does everybody understand the thought exercise that I'm trying to describe? Okay, there are four possible scenarios. Okay, so the four possible scenarios is a blue cat is sick today and tomorrow is indeed doomsday. So tomorrow when you come back to class on doomsday, can you get your $50 back? Not that the $50 is going to matter anyway because it's doomsday, but the answer is no, you are not getting your $50 back because what I told you turns out to be true, okay? Or not false, okay? All right, so what about the second scenario? Okay, the second scenario is you do not find a blue cat that is sick, which means there can be a whole bunch of blue cats. They're all healthy, none is sick, or there's no blue cat whatsoever. Okay, but you cannot find a blue cat that is actually sick. And then tomorrow is also not doomsday. Okay, so the answer is, can you get your money back? The answer is no, you cannot get your money back because I never said anything about what would happen if there are no blue sick cats. That is the key. Okay? So when a blue cat is not sick, okay, when there are no sick blue cats, anything can happen tomorrow because my statement does not cover that case. So let's go through all the cases again. Okay, today you do not find a blue cat that is sick. Tomorrow is indeed doomsday. You still do not get your money back because my statement only says a blue cat being sick today is a sufficient condition for doomsday to happen tomorrow. Okay, sufficient, not necessary, which means there can be a lot of other things that happen today that leads to tomorrow being doomsday. Okay? So the last one is the only time you get your money back. Okay? The only time you get your money back is somebody decides, "Oh, look, that cat is sick. Let's paint it blue." Shh. Okay? And then tomorrow turns out to be just a normal day. You go like, "Tack, where's my money?" Does that make sense? Yep. Yes. Yep, it is not a causal thing. It is really just saying, here's a statement which can be true or false. Here's another statement that can also be true or false. Does the first statement being true automatically lead to the second statement also being true? That is the only question you should be asking. But what if the first condition is false? Then whatever can happen with the second statement. Okay? So that's the intuitive way of looking at implication. So once again, you can look at the intuitive explanation. You can use the truth table, or you can use the expansion of implication using negation and also the OR operator. They all work the same way. It all depends on how your brain is wired. Okay. Some people like, I just use the table. Okay. Look up, easy. I don't have to deal with the semantics. Some people like operators. Okay. I just need to boil everything down to things that I already understand. Cool, not a problem. And then some other people are more semantic. They want to understand the meaning, why it is like this. Then you can also use the example. So whichever way works best for you is the way that you are going to use. Okay, so you will notice that sometimes I'll give you guys multiple options of doing things because they all work. Okay, and I cannot tell you which way works better because it all depends on how you learn. Okay, so that's kind of the important part. Are we doing okay so far in terms of the operators? Yes, go ahead. Uh huh. Right. Yes. Yeah. So this would be the only case where you get a zero because the first condition is true, the second condition is false, so the implication itself is false, and you get your money back. Yes, zero is the time when you get your money back because that's when this is a zero of the implication means my statement that uses implication is false. Yep. hmm All right, so we have one more operator, which is equivalence, okay, but that can also be defined using implication, and you can now see how things are stacking up already in a single class, okay? And typically, topics will stack up in this semester kind of like this. So this is why it is super important to clear all the concepts, to understand all the concepts from a previous class before the next class. Okay, that is really crucial for any type of STEM class that is complicated and talk about abstract stuff. Is to fully understand all the concepts from a previous class before you move on to the next class. Oh, I remember now why I talked about the exams. All three exams are open book and open notes. Now, I don't see anyone saying, "Yeah, that is great," because it's not. If an exam is open book and open notes, okay, not open device, but I don't put a limit on how many dead trees you can bring with you, okay? So for people who are not environmental, okay, they just go like, I'm gonna bring in a big huge pile of paper with all kinds of stuff on it. That's fine with me, not a problem, okay? So what does that have anything to do with note taking? Yes, exactly. Okay, because everything is based on my reading material, which is available to you. It's all already in the Canvas shell. Okay, so that's the starting material. But some people may look at this the way I write and go like, ah, that's an awful way to explain something. Okay, that's fine. Okay, I get it. Okay, so you're gonna write your own notes. Okay, but since you already know the exams are open book and open notes, the question is, what do you think you're gonna bring to the exam to help you in the exam? Your own notes. Okay, so that would be great. Okay, I don't tell people, I do not have study guide, okay, in any of my classes because I'm not you. I cannot write and give you a study guide that works for you. So you're going to have to write your own study guide if that's what you want. So are you going to write your study guide like 24 or 12 hours before an exam? No. Instead, what are you going to do? You write it continuously. That's it's called your notes. So when you're writing your notes, you're also organizing the concepts in a way that you know where to find what because you wrote it. Okay. Now, can you print out all of this stuff here, and bring it with you in the exam? Absolutely. But because you didn't write it, right? So the way I organize, the definitions, the way I organize the explanations and whatnot may not be a natural way for you to actually find the stuff. And that's why, when you're writing your notes, you are helping yourself to kind of gradually create your own study guide for the exam that you can bring with you to the exam. Is that okay? So that means you can plan way ahead of the exams and go like, okay, this is kind of messy. I'm going to spend some time, after class to clean this up. I'm going to move all the definitions to here, all the examples over here, and all the FAQs. Okay, it's going to be here. So spend some time to kind of reorganize if you think it will help you. So that brings up another topic. What does it mean when you are taking a 3-unit class in a semester long class? What does it mean? Okay, so I see, I hear that. Okay, that's good. That's a really good start. So let's go back to the syllabus, okay, because there's one piece of information in the syllabus that is actually useful. It is published in the schedule, okay? That means you have access to this from day one. So that has to do with the number of hours, okay? I'm just double checking the math. It works. Okay, it makes sense, okay? So this is the number of hours. Let me see. It's a 54, 16-week class, 16 times 3. Okay, so this is the total number of hours that the college is expecting each student to spend on this class for the entire class, for this class, for the entire semester. So you go like, it doesn't work out this way. It's not supposed to work out this way. Look at this, okay? We have a 16-week semester, right? And in each week, we have 2 classes. So we have 32 meetings. Each class meeting is 80-minute long. So we multiply that by 80. Okay, so we have what, 6 over here, 2, 5, and then 0. So we have this many minutes. So when you divide this many minutes by hours, okay, you don't get 160. Okay, so let's do it the other way. I'm going to do the long division. I have been told by other professors that people are no longer knowing how to perform hand division by hand. Is that true? No. You guys Okay. So with this one is actually not too bad. Okay. So we have four of those, right? So you have 240, and then you have 160 left. So it doesn't quite work out entirely. So it's like 42 point something, right? So 42 point what? 2, 1240. So with a remainder of 40. Okay. So there we go. We'll call it 43 hours, right? So go like 43 hours. How does that come up to 162? That's because for each hour that you're in this classroom in a lecture, you're supposed to spend 3 additional hours outside of the classroom, maybe at home, okay? Maybe when you're on a bus, okay? It doesn't really matter, but you're supposed to spend 3 hours for each hour of lecture, okay? That's how we come up with 160 because when you multiply 42 by approximately 4, you get 160 something. Does that make sense? So now the question is, what am I supposed to spend those 3 hours doing for each hour of lecture time? Reading ahead, rereading the notes, okay? Just kind of make sure you understand all the material that is taught in the previous class. Reading ahead, okay? Because all the material is already on Canvas. You can read ahead. Reorganizing your notes so that you're turning that into a study guide so you can take it with you to the exam. That is how you can spend the 3 hours for each hour inside a classroom in a lecture. Okay, those 3 hours also include usual study time, which I mentioned already, and also doing your homework. Okay, how many people knew that already? Okay, very good. Okay, so that's important. Okay, because not knowing how many hours you're supposed to spend on each semester for a class means you may not be scheduling, or I shouldn't say scheduling, you may not be allocating enough time, okay, to get all your classes, to be successful in all of your classes. I have known people who take like 22 units per semester. Okay. So even if that person doesn't need to work, that is way too much. Okay. 12 units is full time already, which means you're going to spend about 40 something hours per week on all of your classes if you're taking 12 units. It's like a full time job. So that means 18 units is already 50% more than a typical work week, which is 40 hours. Is that okay? I know some of you are really smart, but smart people get tired too. Smart people are not robots, okay? They will still get fatigue, okay? Yeah, they will still get anxious and stuff like that. So that's why I need to mention this because this is how this semester may be too late for some people. You have already signed up for your 22 units, but when you move on to a 4-year university, make sure that you allocate your resources in a realistic manner. Okay, it does matter a lot. Whether you're kind of pushing yourself, it's like, well, but my friend graduated in 3 years and a half. I want to do the same thing too. Well, you have to look at the price that you have to pay to be graduating like only half a year earlier. Okay, is it worth it? I can answer that question for you, but it's something that you have to think about. Are we good so far? All right. So this is actually kind of important, because now you know how much time you need to spend in a class in order to be successful in a class. Now, does that apply to everybody in the class? The answer is, well, I mean, people vary, okay? Some people really like discrete, and they only have to spend like a small portion of what is, displayed, and but they absolutely hate assembly language programming. So with the assembly language programming, they might need to spend like 4 hours per hour of lecture. But for this class, it's like, oh, this is so natural. I only have to spend 2 hours. So variation can happen, but the 3 hour per hour of lecture is the assumption from my perspective. Is that okay? All right. How many people have taken completely 100% online asynchronous classes. Okay, so how do those hours add up now? What is an hour of lecture when the class is asynchronous 100% online? But it's not the same thing. You don't get the irritation of a professor irritating you in real life. It's not the same thing. Yes, getting irritated by someone in real life, live is different from watching a video, you know, with an online class. I think it's different. All right. So what I'm gonna do now is I'm gonna take roll. Okay, don't do anything yet. I haven't set it up yet. All right. So this is what I usually do. I just give you a access code. So the access code is implication. I will write it on the whiteboard. Implication is the word. And I will give you guys like 10 minutes, okay? So we'll go ahead and go to over here. It's going to be today, and then I'll give you like 10 minutes, okay? I'll give you like a little more than that, PM. Huh? It shouldn't be up yet. It is? Okay, I need to hide it. Give me a second. Alrighty. Okay, so the only question in this quote unquote quiz is whether you're in class today or not. And I always get somebody who's smart and go like, "What if I click no, I'm not in class today?" I will still count you as in class, okay? Because you have to be in class in order to say that you're not in class. All right, so it should be published, and the location where you can find this row taking activity would be in the same module that you find Boolean operators, which is under introduction. So you should be able to find this activity, make sure that you use the access code implication, and you just kind of answer that one little question. You have 10 minutes to do it, or 15. Hmm? You should use the Wi-Fi in school if you want to do this. So are you using your own 4G or 5G? I will have to turn off, yeah, for this time I'm gonna turn off the Wi-Fi, the IP filtering, because sometimes I get people who just ask other people who are in class and go like, "So what's the word today?" And they just do it at home. Okay, you should be able to do it now. I just disable the IP filtering. All right, cool, cool. Mm-hmm. Yeah, I just have to grade it, but that looks good. Yep. All right. Well, the lecture is not quite done yet, but if you need to leave, you need to leave. Hmm? It's not over. I'm just taking roll. The lecture is supposed to end at 1:20, right? Yep. Oh, I don't want to shortchange you guys and then later on get people to go like, I want my refund. You ended the class early. Where's my money? Most of the time I go over, but I won't charge you extra. Yep. So you cannot sign in? Okay. So today you can just email me. I can count you as in class, but you know what to do in future classes, right? Okay. Because this is what I'll be doing. All right. Any other questions? No other questions? Okay, all right. So assuming that we don't have any additional questions, and I'll go back to Boolean operators. Okay, all right. So are we all good with road taking? Any problems? Oh, you're trying to get in? Okay, okay, cool. So knowing this, when you come tomorrow, I mean not tomorrow, Monday, you can basically just pre-sign in on your phone to Canvas, just so that you are already in Canvas by the time I have to take rope, you have your Canvas already, ready to go. All right. So this is the truth table of if and only if, which really is if and only if. Okay. So that is kind of the reverse of exclusive OR. We talked about exclusive OR before. So exclusive OR is the opposite of if and only if. Okay, if and only if means if X is the same as Y, then the if and only if is true. But if they're different, then the operator returns a zero, returns a false. Okay. So now the question is, okay, so we just went through a bunch of material for this particular reading module. What about those links, down all the way down here? So what do we use those for? I'm talking about this, and also this. So what is that stuff? So the first one is the licensing of this material. I wrote this stuff, okay? So if you find any type of errors, it is all on me, okay? There's no publisher to blame. But the specific license also allows you to download all this stuff, print it out at home. You can basically just read the copyright notice to find out exactly what you can do with it. Pretty much everything except that you pretend that you wrote this stuff and sell it for money. Okay. If you give me a share, you still need to attribute to who wrote this stuff. So you still have to do that. Not that this will actually make anyone any money. Discrete math has not changed for the past 60, 70 years at least. Okay. So you can Wikipedia, you can wiki everything that I teach in this class. Okay. So if you spot a mistake, okay, if I make a grammatical mistake or I forgot to close a close parenthesis, and you have a GitHub account, you can click on this link. It will bring you to a page where you can make changes, okay? And then you can submit a pull request in GitHub and just comment and go like, okay, I just fixed one of your grammatical mistakes. And that pull request will get to me. I would evaluate your suggested change and I go like, oh, darn, I made another grammar mistake, and I can accept your pull request. And now you have just contributed to the greater good. Okay. The next link is, let's say, for those of you who don't want to make a change and you just want to rant, okay? You just want to say, Tech is such a horrible teacher, and the stuff he writes, I do not understand at all, okay? You just need an outlet to talk about this stuff. And you go like, yeah, I can do it at ratemyprofessors.com, but they have a limit of how many characters I can actually use in my message. I need something that allows me to write something a lot longer. That is what you can do with this. Okay, it will bring you to GitHub, and then you can have a discussion with other people about the stuff that you want to talk about. Okay, so and then the last two are actually really useful. I will point out each one and to tell you what to do with each one. This one, I'm going to right click and open a new tab because I think it's important to keep the other one. So even without a GitHub account, you can still land on this page. So what you can do now is you can either click on raw and do a copy and paste, or you can just download the original file, which is in Markdown. It is not HTML, it is in Markdown. Okay, so I'm going to do this. I'm going to save this as the name of the module, or I can just describe it in Boolean operators. Okay, so I just saved this as a regular file. It's in Markdown. Does everybody understand what is Markdown in this class? Okay, so Markdown is basically a text type format. Um, you can highlight, you can italicize, you can make bullet points, but it's all actually plain text. But it's a lot easier to type compared to HTML. I can show you exactly what I mean by that. Okay, so if you want to just read the Markdown original raw file, you can also click on raw, and this is the actual text that I put into the system that generates the HTML document that we were using earlier in class. Then you go like, okay, that's a cool, but what do you want me to do with this, right? This is one thing you can do. You go to Gemini, and then you can start with just chatting, okay? How many people know that you already have a Gemini? You have Gemini access as a student of a community college in California. You guys did not know that? Okay, you guys knew because I told you. Okay, so every student in the California community college system has access to Gemini for the next 2 years and a half. It started last semester. Okay, so if you don't want to pay $20, for your own Gemini account, you can use the one that the school has already, or the chancellor's office has already paid for. Okay, so one thing you can do is you can upload the file that I just downloaded. So you go here, upload that document, and then you tell Gemini that I will be asking questions about Boolean operators in following, not in following prompts. Okay, so what this is doing is now you can interact with the material. Okay, you can ask questions. Okay, so you can now say a lot of things. Okay, for instance, you can say, um, give me a quiz to make sure I understand the notations of the Boolean operators discussed in the document that I just uploaded. Okay, and there are variations of this too. You can say, okay, give me a table, hide the answers, blah blah blah. There's a whole bunch of options to do this. So this is using AI to help you study. Okay, not using AI as a shortcut, but using AI as a way for you to go like, did I really understand all the concepts? Am I remembering all the notations and whatnot? So now the um, Gemini just generated a quiz for you. Okay, so let me give it a try. Okay, this is actually new to me too. I didn't know that it can generate something like this. It's fully interactive, which is really cool. All right, so let's see whether tech knows his stuff or not. According to the module, which mathematical symbol represents the conjunction the AND operator? So A is one of those two, but C is definitely one of those. So, oh, mathematical, very good. Okay, so the mathematical one is C, okay, because the other one is computer engineering. Okay, good. You guys are actually reading the question. I didn't read it. I always tell my students, if I were a student of my own class, I would probably be a B student. I cannot be an A student. Okay, in engineering documents, how is disjunctional or often represented for ease of entry? I think that's a C. All right. Which C++ expression corresponds to the mathematical notation with a little cliff thing? I think it's this one. Ooh, that's tricky. I like the AI because all of these can be seen as negation. This is arithmetic negation. This is bitwise not. Okay, so they're kind of related to exclamation point with just a little bit of a difference. There we go. The module mentions a specific symbol used for negation in digital circuit design because the traditional overbar is hard to type. What is it? I think it's a forward slash. Yep. Okay, there we go. Which symbol represents the NAND negated AND operator? It's this one. Sure, there we go. How is the implication operator defined using other Boolean operators? Ooh, look at this. Okay, it's doing a pretty good job. Okay, giving you guys confusing options, which is one thing that I cannot do. Okay, I try to make my own multiple choice tests for years, and it's really hard for me to come up with incorrect answers. My mind, revolves around the correct answer. It's like, how can this be wrong? How can I generate wrong, incorrect answers that are confusing? Well, apparently the AI is doing a pretty good job at this. Okay, I'm impressed. All right. Which of the following expressions using which of the following expressions using the NAND operator is equivalent to simple negation? It's the first one. Okay, but it's good to look at all the possible options. Ooh, look at that. It's the first one. All right. Let's see what happens when I get it wrong. Okay, I'm always curious of what if I click the wrong button? Since this is not a arm, this is not a bomb disarmament, kind of class, I can always push the wrong button and nothing is gonna happen. So with this one, it says, what is the logical definition of equivalence given the text? All right. So I'm gonna answer this wrong. I'm gonna pick something that is incorrect. I'm gonna pick the first one, okay, which is incorrect. Not quite. Wow, this is more encouraging or more gentle than I can be. I'll just say wrong. Okay, I'll just say no, this is wrong. Okay, it says not quite. Equivalence require both directions to be true, so or is incorrect. So let me try the patience of AI. I'm gonna get every single possible wrong answer. Let's pick this one here, which I have no reason why anyone would answer C, but we'll give it. Oh, it gave me the right answer already. You can probably change the prompt and go like, okay, do not disclose the correct answer if I get it right, if I get it wrong. Okay. Oh, that's no challenge. Okay. In the context of C, C++ Boolean values described in the module, which scalar value is considered false? Any even number, -1, 0, or 1. Let's get it a wrong answer too. I mean, this is good, right? I mean, I don't know about you, but this is pretty good. The expression x wedge y is officially represented in math as such, but is often simplified in engineering documents to what? Oh, I like this one. It's this one here. Done. Even scores the whole thing. I think that is pretty cool. I don't know about you, but I think this is pretty cool. One of the things you can do within the 3 hours for each hour of lecture. Yep. I think ChatGPT 5.2 and Gemini 3 are comparable. You can also specify the model too, because when you are using AI, you can see this little drop down here. So you can go for fast, which means it may not give it all the processing that is needed, thinking, or you can use pro. So I typically just default to pro, which means it takes longer for the AI to come back with an answer, but typically it would be more correct or it takes more things into consideration. Gemini is catching up with ChatGPT, and that's why ChatGPT or OpenAI is responding. So, okay, this relates to occupation. What is OpenAI doing these days now that it feels the pressure from Google? It's doing what Meta was doing last year, which is poaching. It's poaching people from other AI companies. It lost a few people to a few other AI startup companies, but many of those people are now quote unquote returning to OpenAI because Sam Altman has been going around to kind of poach people because he's feeling the pressure from from Google. So that means Gemini has to be doing a pretty good job in order for OpenAI to feel that burn and go like, okay, we need to step up the game too. I'm gonna have to poach people from other companies. Yep. Go ahead. Yeah, we're done with the lecture. Okay, so my take, I can tell you what I know almost for sure in terms of vibe coding. I think vibe coding is a thing, but it can only go so far. Okay, now there's a reason why it said that is a certainty. Does mathematics predate computers? Yes. Was Newton using mathematical notations? Yes, right? So why do we have mathematical notation? I could just say multiplication, right? Multiply, integrate, and so on and so forth. So why do we need mathematical notations? So we can understand. So there are two aspects to quote unquote understand. One is mathematical notations are more concise, which means you don't have to write the whole word out and to explain to people. That's one. The number two reason is actually more important. It is more structured. You can use parentheses to clearly indicate do this first, do this next, and then do this last, right? But to express the same thing using a natural language, I don't care which one you use, is difficult. So vibe coding means you are not using a formal notation. You're basically just trying to use normal language to describe what a program is supposed to do. With certain things, it's not a problem. With other things, our natural language lacks the precision and also the structure to clearly indicate what you want the program to do. I'm not even talking about the implementation or how it is done. I'm simply trying to specify what needs to be done. Natural language has its limitations. So I think for problems where it's really difficult for you to use natural language to even describe what it is supposed to do, what the computer is supposed to do, vibe coding is not going to work. So I guess you can imagine there's a threshold. For things that are below that threshold, you go like, yeah, vibe coding is going to work, not a big deal, okay? But for things that are, I'm not done with this class, so can you come back when we are done? Thank you. hmm So vibe coding is not going to work for the more complicated problems. Now, whether that threshold can move, that's a separate question, but I think there is definitely a line where vibe coding cannot cross. And when people try to cross that line, it's painful because the AI doesn't really know what you really want it to do. It will give you the wrong code, and then in the same conversation, you will try to fix it. But that approach doesn't work because of how LLM or large language models work. Because the entire conversation is still within the context. So that means the initial either incorrect or incomplete description is still within the context, the context window. So that means that is in the context window. The additional correction that you're trying to explain is also in the context window. LLMs are probabilistic. Okay, it does a whole bunch of magic, calculation in order to come up with the probability distribution of what the next token is supposed to be. So let's say that there are 6 tokens. Okay, they are almost equal in terms of probability. The AI is just going to throw a dart, see which it lands on, and go like, "Yep, this is going to be the next token." Does it does it know and process the other 5 potential token? With most LLM implementations, the answer is no. So that means if your original prompt is ambiguous, the AI just randomly chose one interpretation out of 6. It doesn't understand and ask you for clarification. It's like, but there are 5 other ways to interpret what you just told me. Which way do you want? It doesn't give you that feedback. It makes an assumption and goes with it. So I think there are a lot of potential problems with vibe coding, which doesn't mean it is useless. I would use vibe coding to set up the baseline of a program. So if I want to make a mobile app on iOS, okay, and I don't want to learn to how to set up I don't want to learn read all the API documentation and whatnot. I'll just go like, okay, give me a template program that includes all the necessary libraries so that I can do my own coding. That has to interface with these devices. I would do that. Okay, that would save me a tremendous amount of time, but I probably won't try to use vibe coding to actually finish the project. Okay. Yep. And I'm not going to charge you guys for for that 5 minutes, so you're safe.